Because liquid nitrogen is so cold and potentially so dangerous, what I am doing is making sure that I am geared up. Okay? Lab coats are not just fashionable, guys, they're actually protective equipment. So, if liquid nitrogen were to spill on my coat or something like that, it's going to roll off. That's also why I have the heavy gloves on. All right, and I also want to make sure to protect my peepers, so I'm going to keep these guys going as well. So let's play around just a little bit with it. First, I want to fill up. I'm going to fill up over here from my liquid nitrogen doer. I'm going to put it in a Pyrex bowl right there.
So is that what they use for fogs and like concerts?
No, not usually. If they're going to use something to make a fog at a concert, it's generally going to be dry ice. Okay, normally liquid nitrogen is a little too sketchy. Mostly liquid nitrogen has, excuse me guys, my phone keeps blowing up on me. Okay, mostly liquid nitrogen is used in industrial applications and medical applications, okay, which we'll talk about a little bit. Now the reason I wanted to use liquid nitrogen today is because we're talking about space, right? Well, these are the kind of conditions you're actually going to see in space. On the dark side of the moon, sometimes it actually gets down into liquid nitrogen temperatures, okay? We're talking negative 278 Celsius, really, really cold stuff. So this is kind of the time when we start playing around with materials and material testing. So first thing I want to show you guys, okay, I'm going to take this off. Nobody's getting near that, right?
What?
I'm going to come over and I'm going to grab my long tongs. Okay.
Can you get inside?
I'm going to grab a rubber band. Okay, let's see. Yeah, let's grab this rubber band. Is that just a rubber band, man? Just give it a little stretch. Just give it a little stretch. Everything all right? Everything good? Normal little rubber band. Okay. Let's see what happens. A normal little rubber band falls into that liquid nitrogen. Now you guys see how the liquid nitrogen is boiling? Okay, this is a full boil, guys. It's boiling at negative 279 Celsius. Really, really cold. It's hanging out at about 79 degrees Kelvin. Kelvin being absolute zero. This is cold, cold stuff. And now, because it's so cold, okay, we have absolutely no stretch to this guy. Okay, in fact, it broke when I tried to squeeze it. But now that it's starting to melt, okay, we're starting to come back to its normal stretch itself, okay? But that first time I tried to touch it, it actually froze. So I'm going to drop it back in and let that freeze a little bit more again. Okay, and make sure there's no nitrogen on it, and just completely splits. You okay there, buddy? All right. So again, that's the kind of stuff that we're looking at. So if an astronaut or NASA is actually trying to build something that's going to go, for instance, to the dark side of the moon, they're going to have to think about this kind of stuff. They're going to have to think about the way their materials actually react in that kind of cold. Okay? So